Good morning, students. Now, I hope that you are all are well and safe at home. Our discussions are going on as usual. We have completed our ray optics. In our last classes, we have discussed some problems also. I have given you some assignment questions which consists of mainly the board questions. I will suggest you to solve all these questions and any query you may ask. I have told you before also. Today's discussion. Our today's discussion is here. A new chapter, new topic I am starting, which is attached to the ray optics, that is the optical instruments. Okay, an important chapter. It is optical instruments. Actually, in optical instruments, mainly we have to discuss microscopes and telescopes. Okay, we have to, in optical instruments, under this optical instruments, mainly we have to discuss microscopes and telescopes. Alright, these two are mainly in our syllabus. Mind this, I am going just according to our syllabus as prescribed by CBSE. Here, microscope. Microscopes are actually the instruments, the optical instruments with which we can see clear and magnified image of very small objects. Clear and magnified image of very small objects. That device, the device which does it, that is known as a microscope. Alright, so let us today first we discuss regarding the microscopes. Under this head of microscopes, our first discussion is regarding simple microscope. Okay, simple microscope. First of all, I just tell you what is a simple microscope. As its name is simple microscope, this simple microscope is also known as the magnifying glass. Okay, and it is very simple thing. It is, in this case, actually a very short focal length, a lens of convex lens of very short focal length is used, and an object is placed very close to it, the lens, and its magnified image can be formed. It's very simple device. As its name is simple microscope, its device is also very simple. Here we are to discuss this device under the two heads. Number one, this is the first head. When final image is formed at the least distance of clear vision. Look, what is least distance of clear vision? Least distance of clear vision means it is D is equal to 25 centimeter. I hope most of you know it, that for our normal eye there are two important points. One is the near point, another is the far point. Far point is infinitely large, but near point is 25 centimeter. 25 centimeter is the numerical value and its notation is capital D. Okay, so that is capital D is its notation. That means up to this distance 25 centimeter, the image can be seen very clearly. And what will be the position of the eye in all these optical instruments? The position of the eye, the most convenient position of the eye should be very close to the optical center. Right. Okay. Our first discussion, again I am going to that. When final image is formed at the least distance of clear vision. Okay. The figure is this. I just once discussed this figure, although this figure is very well known to you. I hope all of you know it, but I just tell you, this is our convex lens of focal length, say small f is the focal length of the convex lens, and this is the principal axis. On this principal axis, here in between optical center and the principal focus, there is an object AB placed. Its ray diagram will be, okay students, in this context I tell you try to draw always the ray diagrams with the pencil. right? And with the proper scale drawing. Although I have drawn it with freehand, but you will draw in your copy on your examination paper also with the help of the pencil and the scale. You will use proper scale. Proper scale means, look here, F, okay? On this side also I will mark F on at the same distance as this OF, the same distance here also. Okay, that is called the proper scale drawing. And then you draw an object. It's a linear object AB. From here 2 rays are going. There are so many rays may travel, but I have shown here 2 important rays. One passes through the optical center, you know, that ray will go undeviated. Another will go straight parallel to the principal axis. Thereafter it will pass through the principal focus. Obviously there will be diverging rays in this way. If they are produced in the backward direction, a virtual, erect and much magnified image A1, B1 is formed. I tell you, what type of the image? It is the virtual, erect and much magnified, very much magnified. A1, B1 is formed on the same side as that of the object with respect to the lens I am talking. Right? Here is the optical center. The most convenient position of the eye is here, which is very close to the optical center. Followed? It should be very close to the optical center. It's like this. Look at this figure. I hope this figure is very clear to all of you. Clear? Now what I do? This is the first case we are discussing. What I have to do in this case, now when the questions are asked, you have to find out the angular magnification, which is also known as the magnifying power. I have written here the definition for the simple microscope in this adjustment. In this adjustment for the clear vision, I have shown here. Look what I have written. Angular magnification or magnifying power is the same thing of a simple microscope is defined as the ratio of angles subtended by the image. Just see, angles subtended by the image and the angle and the object. Ratio of what? Angle subtended by the image to the angle subtended by the object. Okay. When both are at least distance of clear vision from the eye, that means last clause is very important. This last clause, this last, you can say, part of this sentence, last part of the sentence of the definition is very important. When both are at least distance of clear vision, that means it is intending to say that the object and the image both are at the least distance of clear vision, isn't it? Object and the image both should be at the least distance of clear vision. How it is possible? Now see, first of all, we shall adjust the lens, the object distance of the lens from here in such a way that the image must be formed at 25 centimeter. That can be done very easily. You understand how? I just explain you. What is our formula? 1 by V minus 1 by is equal to 1 by F, isn't it? This is the formula, lens formula. So if I take a particular focal length, lens of a particular focal length, and we choose a particular object distance, I hope that can be achieved. That V should be 25 centimeter. I hope you got. So our intention will be to form this image A1 B1 at least distance of distinct vision or clear vision, that is 25 centimeter. That means what I say, V is equal to D. Which distance? Just mark it. Are you agreed? This distance should be V is equal to D. Obviously this distance is V, image distance, and this should be equal to capital D. Followed? Okay. But one thing it says, ये जो इमेज जो बना वो तो 25 सेंटीमीटर पर बना, बट उसमें जो बोल ऑब्जेक्ट भी 25 सेंटीमीटर पर रहना चाहिए. फॉर दैट व्हाट आई हैव टू डू, आई विल कट BA equal to B1P. Understand? We cut an intercept. BA is equal to B1P. Okay. Look, BA is equal to B1P and we join PO. I will join PO like this. This we have done in the construction. Now it is there. See, image is also at least distance of clear vision. Object is also at the least distance of clear vision. I have shifted its position here just by cutting an intercept. Okay. Then now let us see angle subtended by the image. Let us say it is beta. I am talking about the angle A1OB1 and another, this is POB1. This angle is alpha. Angle subtended by the object. It is said at the eye, but since the eye is very close to the optical center, the same will be taken as the optical center also. Alright, then what we shall take? M is equal to M is equal to beta by alpha. According to this definition, beta, angle subtended by the image and the eye to the angle subtended by the object and the eye. Beta divided by alpha. Very simple. Beta divided by alpha can be written as, it is tan beta by tan alpha. I write here for small angles. And what is this? This is tan beta is what? A1B1 by OB1. A1B1 by OB1 divided by here tan alpha is PB1 by OB1. PB1 by OB1. I cancel these two. How much we are getting? A1B1 by PB, which is equal to A1B1 by AB. What are these? Size of the image by size of the object. Are you agreed? This is equal to small m. You know, it is called linear magnification. It is called linear, I write here in this way, linear, in short I have written magnification. You look, what we are getting ultimately? We are getting here that the angular magnification is equal to the linear magnification in case of this here. Angular magnification is equal to the linear magnification, isn't it? We are getting it for, but mind this, angular magnification is not always the linear magnification. It will not always be equal to the linear magnification. It is equal to this here in this case. Obviously, it may be written as V by U, no problem. You know, that is size of the image by size of the object is equal to distance of the image by distance of the object. That also occurs. Now I take this lens formula. Okay, use here the sign convention with, I write here, sign convention. Look what I am doing. V is negative, minus U is equal to 1 by F. Can I write it? Look, I have taken V to be negative, U to be negative. It can be written as this. Now, multiplying both sides by V, can I write minus 1 plus V by U equal to V by F?